Let's take a look at creating a mirrored feature this evening. So starting with the normal process of going through and actually getting into that part workbench, we'll just start out there and kind of go from that initial start point, jumping into a sketch, of course, to actually work with our part file. So in this case, we kind of want to take the profile that's going to be the most effective for us. So in this instance, it would probably be that L-shaped pad. I'll step in here and grab that ZX plane. Once on that, I'll probably take advantage of the profile tool found over here on the right-hand side. That's going to allow me to quickly come in and generate that geometry, and then come back through and constrain it. So right now, of course, we have those automatic geometric constraints in there. We just want to step through and add some dimensional constraints to it. So we'll set the overall height. In this case, we would want to take a peek at what's over here. So if I grab onto this guy, we can take a look. Notice that it has 20 for the pad height at the bottom, plus 70. If we remember, we can actually add that up pretty easily in Catia. So I'll just come in 20 plus 70. Hit OK. That's going to, of course, allow me to actually input that measurement. I take a look in the top view here. That's letting me see that it's 100 in that dimension. We'll add that value there. And then, of course, we'll just come through and basically complete the other pads, both 20. Once we have that accomplished, we'll exit the workbench. That'll let us come in and actually create some positive geometry. I'll use pad to do that. In this case, I'm just going to flip the direction and just extrude it out and to the left. Notice that most of the dimensions on this particular model are halved, just for ease of reference in this type of situation. It happens to be 130 millimeters overall, or excuse me, for half the distance. So I'll hit OK with that. It's going to create that 130 millimeter projection. At that point, I'll probably step in and start constructing this boss. We can actually step in with another sketch, selecting that pre-existing geometry. I'll take advantage of the profile tool again, kind of create that shape. In this case, I'm just going to create a pretty simple rectangular shape, making sure to make contact with each of the points, taking advantage of that origin to actually define two of the sides, so then I can come back through doing the control select, just picking line segments and edge segment, and then setting a coincident. Once I've done that, I can come through, develop that depth. If you notice here, it's 20 plus 50, so we'd have a total of 70. I'll complete that, come through, pad it, reverse the direction, take a look at my dimension, it happens to be 60. You can hit OK there. At this point, I'm going to come through and I'm going to create a pocket in the front, so I'm just going to select that front surface. And what we're going to do is take advantage of that profile tool again. And in this case, what I'm going to do is come down and kind of make that horseshoe shape. I'm going to toggle over to a tangent arc, pull that all the way over. It's going to automatically transition back to a line segment and allow me to kind of complete that tombstone shape. And then I'm just going to kind of take advantage of that guy. I'm just going to come in, maybe take a peek at adding a vertical constraint here. So I'll come over to constraints defined in dialog box, maybe set that guy vertical. It's going to lock that in place. I'm going to tie the center point of the arc to that vertical edge with a coincident constraint. That's going to allow me to dynamically change that guy and kind of manipulate it, making sure that this is always tied to that edge. And then the process is just going to kind of continue. I'm just going to come through, add a dimensional constraint, defining that as a value of 25 over. As you can see over here, I will locate vertically that point from the top edge, as you can see here, of 35. And at that point, I would probably just come in and constrain those two together with a coincidence. So we have a fully constrained sketch. Everything's green. We'll exit the workbench, placing this back into that part workbench or part design workbench. I'll come through with pocket. In this case, I'm going to do an up to last. to remove that entire geometry set, hit OK. All of this stuff, of course, things that we played around with in class pretty successfully. At this point, it's just a matter of doing a couple of dress-up features. If you remember Edge Fillet, that would be a good one to actually come through and add these radiuses that you see here. So in this case, it happens to be a radius of 20 in both spaces. So I'll just come through, breaking those edges off. I can hit OK there. It's going to break the edges for me. Other things I might want to do, I might want to walk around that bottom edge. If you notice over here, it's showing a radius, a radius, a radius, and a radius. In that case, what I want to do is take advantage, again, setting that to 5. One thing to note, if I have a pre-existing tangency, by selecting an edge that runs into a tangent arc, it's going to continue the path around. So it's going to save me some trouble. So if I pick here, didn't want to pick the whole face, just the edge. Pick this back edge. It's going to wrap it down and around. What you'll notice is when I get to these surfaces, though, I'm going to have to pick, because there doesn't happen to be a fillet in this corner. So it doesn't automatically wrap around in that instance. In this case, I'll hit OK. It's going to create all that filleted geometry. I might want to come in at this point and pop a hole through. It's going to come out. Grab that surface. Remember, we can use a positioning sketch to locate appropriately. I need to pay attention to the size. It happens to be a 15 through all. So in this case, what I want to do is set my diameter to 15, set my extension to up to last. Make sure I actually type that in right. 15, go to positioning sketch. It's going to put me active into that sketch mode where I have that node that allows me to actually position the sketch. So in this case, I'm just going to come in, take advantage of that outside arc plus a selection of that point, and we're going to set those so they're concentric with one another, so it's locked in relative position to that at all times. Up to last, that's all happy, we'll hit OK. And at this point, to finish this model up, a couple of things need to happen. We introduce the concept of using a chamfer in this instance. That happens to be found here. Notice that it does give us an icon that represents that style shape. We'll select chamfer. In this case, if I take a look, it happens to be 30 millimeters at 45 degrees. Very similar to the functionality that you find in Edge Fillet, except of course we have a couple of different modes. In this case, I'm going to stick with the length and angle, but you do have length, chordal length, and angle, height, and angle. So we're just going to stick with 30 at 45. Select the edge, OK. And at that point, it's going to be pretty easy to come in and finish this because we can take advantage of the symmetry of this part. I'm going to go up to Insert at the top. We're going to locate transformation features. Within transformation features, I can find mirror. What it's going to ask me for is a mirroring element and an object to mirror. Now note, typically Catia is going to select the current solid. You could go through and individually pick specific features. In this case, though, we do want to actually mirror the entire item, and I can use one of the model's faces as my reference plane to mirror. If I hit OK, it's going to generate that other geometry, and we're done with that particular part.